Today I'm going to talk about diagram class, where a class diagram is used to visualize the relationship between the class that involves the system, which can be associative type, inherit type, use, and concept. And this is class attributes, methods, and visibility, and in the relationship inheritance, composition, aggregation, association, and use. The elements of this diagram are the class. It is the basic unit that encapsulates all the information of an object. Through it we can model the studio environment. In the top we have contents of the name class, and intermediate contains the attributes that characterize the class. And in the bottom contains the methods or operation which are the way of the object which are the way that object interacts with its environment. And here is an example. The class is Cuenta, and the attributes or characters of the class can be one of types which define the degree of communication and visibility of them with the environment. These are public, private, and protected. Public indicates that the attribute will become visible both inside and outside the class. That is, it can be accessed from all sides. And private indicates that the attribute will only be accessible from which the class. Only its methods can access it. And protected indicates that the attribute will not be accessible from outside the class, but it can be accessible by methods of the class in addition to the subclass that are derived. The methods or operation of a class are the way in which it interacts with its involvement. These can have the characteristics. Public indicates that the method will be visible both inside and outside the class. That is, it can be accessed from all sides. Private indicates that the method will only be accessible from within the class. Only other methods of the class can access it. Protected indicates that the method will not be accessible from outside the class, but it can be accessible by methods of the class as well as methods of the subclass that are derived. See inheritance. The cardinality of the relationships indicate the degree and level of dependence. They are written down at each end of the relationship, and this can be one or many, zero or many fixed number. Inheritance, specialization, generalization. In the case that a subclass inherits the methods and attributes specified be a superclass. Therefore, the subclass, in addition to owning its own methods and attributes, will possess the characteristics and visible attributes of the superclass. Aggregation. The model complete objects, the basic data types provided by the language, are sufficient integer, real, and sequences of characters, like a string, when it is required to compose objects that are instances of class defined by the developer of the application. We have two possibilities, by value, by reference. By value, it is a type of static relationship where the lifetime of the object includes its conditioned by the lifetime of the person who included it. This type of relationship is a commonly called composition. By reference, this is a type of dynamic relationship where the lifetime of the included object is independent of the one that includes it. This type of the relationship is commonly called aggregation. Association. The relationship between classes known as association allows you to associate objects that collaborate with each other. It should be noted that it is not a strong relationship. It should be noted that this is not a strong relationship. That is, the lifetime of one object does not depend on the other. Dependency or instance usage. It represents a very particular type of relationship in which a class is instantiated is denoted by a dotted arrow. The most particular use of this type of relationship is to denote the dependence of one clause on another, such as a graphic application that initiates a window. And that's all. Thank you for watching.